Okay, so for g, okay, you'll notice we've got v squared plus 9 on the denominator, but we've also got a v then in the numerator. And when you look at the standard results that we've got here, none of them are going to apply, aren't they? Okay, none of them will apply because here we've just got constant 1 on the top, but here we've got the variable v. So question is then, how do we go about it? And quite simply, we need to refer back to the result we mentioned at the start, this result here. Okay, because if you've got the integral fraction here where the function in the denominator, when differentiated, gives you the numerator, then the integral will be ln of the denominator. Okay, when you look at what we've got here, well, if you differentiate the bottom, you get 2v, don't you? When you differentiate this, the 9 will be 0 when you differentiate it, so it's just 2v. And when you look at the top, well, it's not quite 2v, but it's close, isn't it? It's kind of like half of it. Okay, but what we can do, we can be slightly clever, right? We can rewrite this integral, okay, and we can make it so that we've got 2v on the top. Okay, so the question is, how do you do that? Well, let's just rewrite that v squared plus 9 dv, okay, and v on top. But as I just mentioned, you know, when you differentiate the bottom, you get 2v. Well, let's chuck a 2 at the top then, okay. Now the question is then, how do we go about equating these? How do we go about making them equal? Okay, because that's what I want, isn't it? All right. I want to make these equal. So how do I do that? Okay, well, what I can say is the integral of v over v squared plus 9 dv is equal to, well, it's certainly not equal to that, but what I can say is this integral is equal to 1/2 of this integral. So if I put a half in front, what actually is happening here then is the 2's would cancel, yeah? Because I'm saying that this integral here, v over v squared plus 9 dv, is equal to half of the integral of 2 lots of v over v squared plus 9. Do you see where I'm coming from? So I'm doubling v here, okay, and you compare it to that, but then once I've formed the integral, I'm halving it. So we can say then they're equal. And you just need to see that the 2's would cancel there. Okay, so whatever we need on top, okay, in this case we need a 2 there, because when you differentiate this you get 2v, so we need a 2 there. Well, you need to think, I need to pay back, okay, so because I put a 2 there, I'm timesing by 2, so I pay back on the outside, I times it by a half, and of course then a half times 2 is just 1, so we get these to be equal. And what's good then is, when I do my result, okay, well, I've got this half outside, yeah, half of it, so I need to have that there. And then the integral for this there, well, quite simply, because when you differentiate the bottom, now we get the top, 2v, okay, then this situation applies, okay, so we just say it's ln of the denominator function. So we just say then ln of v squared plus 9, okay. Don't forget the constant there at the end. Alright, we've established a way of doing that then, okay, by simple cancellation there. The process will work for us.